Good morning, and welcome to another edition of NovaTech's Power Hour. My name is Ben Gratsky. I'll be one of your presenters this morning, along with Suraj Rajpal, one of our sales engineers out of Toronto. We also have Nate Irvin, our Kronos product manager, available to take questions. Let's move on. So today's topic is going to be our line of Kronos satellite clocks. We're featuring the Kronos 3R, one of our new releases. Today's agenda, we'll be going over our line of clocks, show you the 3 different models we have, do some comparisons, and we'll talk a little bit about some of the time synchronization protocols we have available, and we have a couple troubleshooting tips and some clarifications on online and offline configurations you could do with our clocks. And then Saurabh will proceed with an online demo to highlight some of the features of the Kronos 3R. If you have any questions, feel free to post them in the chat, and we will answer them accordingly. So moving on, I'm going to hand it off to Saurabh, and he will show you our line of Kronos clocks.
So yeah, thanks everyone for joining, and sorry about the audio issues there. I hope you can hear me well now. So today's topic is on Kronos satellite clocks, and then what we have is we have Kronos satellite clocks which are made in the US, and then they're backed up by 10 years warranty worldwide, hassle-free, no questions asked. I will be covering the product portfolio of the 3 Kronos clocks we have. Moving to our first product line, which is Kronos Series 2P. This is a small advanced feature, a small size, a small form factor. It's a cost-effective time solution for our automation and control solutions. Some of the key features on this one is the LED display on that. It supports NTP server, also has high and low voltage power supply options, depending on whatever power supply you have at your substation or your industry. We're able to provide both options on this. It can support up to 4 unmodulated or demodulated signals, and then 2 modulated and 2 fiber IRIG-B outputs. So this is like a small half rack unit clock, which is panel mount. That's one of our form factor. I will be jumping into the 2R series, which is a 19-inch rack mount. This is kind of a high density timing, typically used for power systems. This has, compared to the 2P, it has 12 unmodulated and then 6 modulated or 6 fiber IRIG-B outputs. So this is a product order option, so you can choose based on your needs, depending on how many IEDs that needs synchronization. And it also has an optional second network port that also supports bonding. And then moving to our 3R, which is our brand new clock. This is very state-of-the-art clock, typically used for a wide variety of applications such as mission critical power systems and digital substations. Some of the key features on this one are, of course, NTP server is common, but it supports PTP as a grandmaster clock. In this 3R, we do have an option of high and low voltage redundant power supply options. So you can have multiple power supplies. In case one goes bad, you can power on the second power supply. Up to 12 unmodulated signals, 6 modulated or 6 fiber IRIG-B outputs. It does have the option to upgrade the crystal from TCXO to oven control crystal oscillator, which is very handy for longer holdover in case it loses tracks of satellites. It also has PRP, HSR redundancy support on that. And on this clock, it supports up to 72 channels with approximate 20 nanoseconds of time accuracy. So these are the three main form factor of our Kronos clock product line. Let's take a look at a feature comparison between the three. So here I have a table which on the left hand side there is feature comparison, and on the right hand side table you can see the 2P, 2R, and 3R. The orange markers are what is the distinction between the other clocks, and let's just go through that. So in terms of mounting capabilities, the 2P is a panel mount, whereas 2R and 3R are 19-inch rack mount. The time accuracy on the 2P and 2R are very similar, plus minus 16 nanosecond. And on the 3R, you can see it has a higher accuracy of plus minus 20 nanosecond. The temperature compensated crystal oscillator accuracy is kind of similar, plus minus 0.1 ppm throughout. But in the 3R option, you do have the option to get the OCXO instead of a TCXO for better holdover accuracy. In that, it can have up to plus minus 1 parts per billion. Alarm relay contact is common between the three product lines. And then the antenna connector is typically TNC in all three, but we've added a F type of connector with 75 ohm as an option on the 3R. This is typically in case you have a legacy clocks that you're replacing and you have a 75 ohm antenna, you can just have that option as an order. So that way you don't lose your antenna. You can use the same antenna and mount our clock there. Standard Ethernet ports, one RJ45 on the 2P, up to 2 RJ45 on the 2R, and standard 1 RJ45 on the 3R. However, with the SFP, you can have up to 4 more slots on the 3R. So that's kind of unique for, of course, PRP and HSR solutions. You would need more NIC cards. NTP is common throughout the board. IRIG-B, you can have different modulated, unmodulated, and fiber outputs. The 2R and the 3R are kind of on the same spec, whereas 2P, considering the form factor, smaller factor, has relatively less IRIG-B. It really depends on your use case application into how many devices are you syncing over IRIG-B from the clock. So based on that, a decision can be made whether 2P is better for you, or 2R or 3R. Another advancement on the 3R is the 1588 PTP. We do have different PTP profiles, anywhere from UDP 802.3, the C37 to 38 2011 standard, and then an enhancement on that on the 2017. And then we also have the 61 and 59-3 standard we support on that. So these are the PTP profiles we support as of today. And moving on the PRP, that's exclusive to the 3R. And the redundant power supply is also on the 2R and the 3R option. So that's in a nutshell a comparison of form factor, just a high level key comparison on the three product line. Like I said before, it really depends how many devices do you have, and whether you want to use network time protocol or IRIG-B or PTP. That kind of depends on the use case, case-to-case basis. Here I will pass the ball to Ben. He will be diving into this from now on.
Thank you, Saurabh. Very informative. Let me get my screen going here. So one of the key features of our Kronos line is our support of multi-constellation. So we have access to the Global Navigation Satellite System, the GNSS, but we also have capability to connect to GLONASS, Galileo, and Beidou constellations. And the Kronos has the ability to reduce holdover time by connecting to these, several constellations and maintaining signal integrity. We also support faster lock time because we have access to these other constellations. If you notice, Galileo has asterisk next to it. That's because on the OCXO option of the Kronos 3R, Galileo is not supported at this time. So this is just a visual representation of your Kronos connection options. And these depend on what output modules you select for your Kronos clock. Yeah, we're just showing just a representation of what you would have when you set up our clock. And different physical media options. So moving forward, we will be discussing some of the protocols that we support with our clocks. So Saurabh mentioned all three of our Kronos clocks support NTP and SNTP, network time protocol. Works well in local area networks. Minimum hardware requirements, accuracy of up to 1 millisecond depending on your network topology. But yeah, moving on, I think Saurabh, you'll be going over the rest of the protocol options we have.
Sure.
Let me hand it back to you.
Thanks. Yeah, so let's discuss about IRIG-B. That's one of the most widest used in the utility automation world. In case you don't want to go network option or coaxial is the way. So let's look at the history. So IRIG-B stands for Inter-Range Instrumentation Group. IRIG, it has different A, B, C, D, E different chords. It's originated in 1956, 1960 era. It uses a range of codes, which we'll look in the next slide. But time code B is typically used in utilities transmitting at 100 pulse rate. It offers modulated and unmodulated signal that we support both, also known as demodulated. Some vendors like to call it demodulated instead of unmodulated. And then when would you consider IRIG-B or NTP, PTP, or DNP time, right? Well, it depends on how many devices do you have in your substation that require synchronization. That's the question you need to ask. And then whether all IED do have IRIG-B protocol, in the sense, do they have an input where it can receive time from a clock? That's a second factor. The third factor is how long are we running the distance, in the sense that, okay, for every substation, would you have a clock, and then from the clock you would distribute time to, say, every rack gets 6 or 7 devices that can be synced from one output, and so on. So it has to be designed through it, but it really depends on what's the distance overall, and how many devices are you trying to sync in your substation there. So let's look at this is often I get asked on what time code options do we support. In terms of IRIG-B, what we've done here is just decoded what does the B000, B002, and so on, B120, what does it really mean? So we've kind of decoded on this. So if you look at the format, the first option here on the left-hand side shows B006 as an example. The format is A, B, D, E, G, or H. And in our case, we're showing a demo of B006. The first format is B, and then the second digit is 0. So if you look in the table on the right-hand side, the first digit 0 means that we're sending an unmodulated DC level shift pulse width coded. The second digit is another 0, which represents the carrier frequency and resolution. For a B006, that would mean there is no carrier. And then the third digit, which represents the coded expression, is 6. And the 6 means BCD toy, BCD ear, which means binary coded decimal time of the ear, and then of course the BCD ear. So similarly, the one main thing on B000 and B120, sorry, is majorly the difference between an unmodulated or demodulated signal versus amplitude modulated. So similarly, if we had to decode what is B120, that would mean an amplitude modulated sine wave carrier with 1 kilohertz, 1 millisecond resolution. And then, of course, 0 would mean the time of year control function and straight binary seconds. So it's very easy, it's very handy, the slide. So in case you wanted to see what control functions is it sending, it's important to understand what time code options are we sending. Typically, we've been using B004 for demodulated, unmodulated, and B124 typically for the modulated schemes, but B126 and B006 is also the newer versions of it. Next one we have is the 1588 PTP, Precision Time Protocol. This is, I'd like to call this is very similar principle of network time protocol, but with just higher accuracy. It also has a dedicated timing hardware. How it does that is we'll go through the timing diagram shown on this in a minute, but it uses a best master clock algorithm to decide which clock is the best based on different packet communication between the clocks. In this example, we're just showing you one grandmaster clock and one slave or ordinary clock receiving the time, and just going through the correction of the time from the grandmaster to the slave. The sync accuracy is on the order of nanoseconds with the hardware option. Without the hardware option, you would probably get the accuracy of 10 microsecond to 100 microsecond range. In this right-hand side timing diagram, the grandmaster sends a sync packet first, which says, here's the time. The slave or ordinary clock records that, and then the master sends a follow-up message to represent when was it sent. So it tells what the time is, and the follow-up is sending when the time was sent. So it records that, and then this is one-way directions. The total time correction has to happen bidirectional. So the second packet is sent by a slave on a delay request. It sends a delay request, and the master sends the delivery response for the bidirectional correction. And this happens every 1 second or 2 seconds, depending on the PTP profile you use. And this happens constantly, and the slave device constantly corrects its oscillator based on whether to ramp up or ramp down the oscillator based on the corrections. So that's why it's very, very accurate on using the network. One of the advantages of PTP is that you don't need coaxial cables, and you can just run it over the Ethernet traffic itself, so it can get PTP over that. This example is very simple, but in a real use case, you would have multiple. You might have multiple grandmaster clocks and maybe a bunch of ordinary clocks, and then boundary clocks and transparent clocks. So the topology would be a lot more different to what we've just shown. This is just the idea so that people understand how does PTP work behind the scenes. Okay, and let's jump into what are the supported profiles. We mentioned briefly on earlier slides what PTP profiles we have. So here's we've done a comparison where there is a profile, the description, what are the accuracy, latency, and complexity, and what a typical use case would be for one profile or the other. So the standard UDP profile, it's relatively simple, lightweight, doesn't take a lot of bandwidth, but not very optimized for time synchronization. In terms of the accuracy, it's a moderate accuracy with higher latency and low complexity. Typical use case for UDP would be basic communications for less critical applications. On the second profile, 802.3, that's typically used for Ethernet protocol for wired networks, and then it has higher latency than dedicated profiles like power profiles, which we'll see in the next table there. The 802.3 has a moderate accuracy with moderate latency and complexity. Some of the use cases for this profile would be industrial and commercial networks where moderate accuracy is enough, right? The third one is the IEEE C37-238-2011. That's standard PDP profile for power systems. It offers good accuracy and performance with a high accuracy, low latency, and moderate complexity. Some of the use cases would be substation automation, differential protection, and wide area monitoring. These are just few of them you could be using for other applications if it allows. The fourth one is the enhanced version of the 2011 standard C37-238-2016. That's just improved accuracy and features compared to 2011. It has a higher accuracy with lower latency and moderate complexity. Some of the use case would be fault location and synchro phases. Jumping on to our counterparts, IEC 6159-3. That's another standard PDP profile. It's typically used in Europe or for 6150 projects. It has a higher, very similar accuracy, latency, complexity to a 2011 standard, and used in substation automation, differential protection, and wide area monitoring. So these are the key PDP profiles we support as of today, and in the future there might be more that's coming. Okay, with that being said, Ben is going to talk on PRP, how that works, and he's going to give you an example on the network topology. Ben, it's coming to you.
Thank you, Saurabh. So the Kronos 3R does support PRP HSR. So here on the slide, we have an example network topology of a PRP. For those who may not know, it stands for Parallel Redundancy Protocol. As you see in this topology, we have a LAN A and a LAN B, and all of the IEDs are connected via ring bus to the two switches, and those all connect to the Kronos 3R, which serves as a PTP grandmaster in this situation. Just an example of how you would implement PRP topology in the substation environment. So our next slide, we put together some troubleshooting tips, mostly focused on hardware problems that may be encountered while setting up your Kronos clocks. Nothing really to call out individually here, just some tips and tricks. Next, we have a view of the Kronos 3 web interface. We'll be stepping into the demo portion of this shortly, but before we get there, this slide highlights some of the different options you have for setting up the Kronos clock. Some things are available online, and some configuration options are offline. So this will be highlighted during the demo, just telling you some of the capabilities and some of the configuration options. So Saurabh, are you ready to step into the demo?
Sure. Please, yeah.
Okay. I'll transfer this over to the demo portion. Saurabh will be showing you the web interface of the Kronos 3R clock.
Okay, thank you. Okay, so here I have a Kronos 3R at my desk. I've just typed in the IP address for it. It's asking me the password for it, which by default is NovaTech. We do recommend it to change it once you have it in your system. This is what the dashboard would look like, and then to make any changes, you have to put in another password one more time, which I'm going to do that. Okay, so this is a sky clock. Just a heads up, I don't have a physical antenna connected to it, so I'm using a fake time to show the demonstration purposes. On the right, on this sky plot, you could see different constellation that it's syncing to. the orange being the track, the GPS, the green being in use. The bigger the radio button means the higher the strength. On the left-hand side, this is the UTC and EST time. I'm in East Coast, so of course it's showing you EST time. And then the status of the clock, it shows you whether the GNSS state is locked or not, and whether the antenna state is okay or not. Also shows you how many tracked satellites we have and how many out of that is used. Typically, you would need 4 to be in lock state. And then on the general section at the bottom of this page, it shows you what the identifier of this clock is. You might have an engineering name of a clock that would display here. I've left it to default Kronos Series 3. I'm in Canada, so location could be your substation, contact a name or number, and then the model number, serial number, firmware version can be found here, along with the user manual and SNTP MIB file can be found here. So this is like the dashboard when you first log in after your password credential. This is what you would see. I'm going to be covering each of these tabs here. Let's go on the general. So this is where you could change to whatever identifier, location, and contact and save it. We'll show you on the dashboard. The time. Now, time is something, depending on where you are located, some do have DST, some don't have, depending on which part of the US or Europe or wherever you are. So you can choose the time zone to be UTC or depending on whichever state you're in. And then you can set the offset and then also do the daylight savings time based on your geographic location. So in the DST section, I have it in US, but you can use Western Europe, Central Europe, Brazil, and in fact custom. So you can define when does the DST start and when does it end, and then hit save. I'm just going to leave it to US. Moving on to display option. This is a setting what your front panel of the clock would display. You have a various option to display whether you want to show on the front panel or LED. I have it to date, month, hour, minute, seconds, but you can have it to hour, minute, seconds plus number of satellites or offset or day of the year. So you can choose any one of them depending on whatever you wanted on the front display. Let's move on to the output. So the option on 3R I have unmodulated signals on 2 outputs. And then I'm using B004, which we covered different time code options in our presentation. And then you have the option to choose UTC or local time. The options for output are again IRIG-B002, B0002006, and then of course PPS or PPM as well. Similarly for output 2. So this is where you would define your IRIG-B depending on what you want to send, the time code options, and the UTC versus local time. And each output can be different time code options. Let's jump on the network. Gateway, if you are routing some information through, you would put in your gateway address here. I have a port A, which I'm logged into this IP address you can see on the web server. And then port B is where you would set up for PRP or HSR. The redundancy mode can be simply chosen by selecting PRP or HSR, whichever redundancy mode you select, and you would just save that. So port B would be a PRP port then. That's on the PRP. Let's look at the NTP. You can have port A or B, any one of them, to enable NTP. These are some metrics where you can select when it goes on holdover mode versus when does it show you a low quality stratum, and then when does it show you a bad time stratum. So these are numbers you can define based on your, depends on how many layers or how many hops away you have from the main clock to different NTP server devices. And then we have the PTP option. Port B is the only port we have currently which supports PTP. You would enable, and then you can select the profile that we just discussed. So we discussed about UDP 802.3, the 2011 and 2017 power profile standards, and then the 61850 standards. And then we also have a custom where you can define your own metrics. Typically, if you're using the 6150 utility profile, all the grayouts outs are already populated. You don't have to change them apart from the VLAN enable. If you are using a VLAN, which I'm sure you would be using on 6150, you can put on the VLAN ID along with the priority of the packets, how quickly can they go through the switch. So that's that. And then the Grandmaster ID, the domain and priority 1 and 2, you have to define. It's simple. We recommend you to use the online window for PTP instead of the offline mechanism. It's just a drop down. As we populate more profiles, they'll just be in the same drop down with more profiles. SNMP, there are 3 versions we support, V1, V2, V3. Depending on which SNMP you're using, you can choose private or public, and then the trap host, define it, and then just save it, depending on V1, V2, V3. Going to the GNSS, the multi-constellation support, I have it, my clock as GPS, Galileo, and GLONASS. You can use up to 3 of them in parallel. And then you can also define out of bounds limits in terms of when would it alarm for a bad time and when would it do a low quality in terms of milliseconds. Moving on to access, these are where you would change the password. I have for configuration, firmware, status monitoring, all of them to be NovaTech. We highly recommend you to change it to something stronger password for this. And the last option is enforce HTTPS over HTTP. We also recommend you to use always for HTTPS. So that's kind of in a nutshell. I know it's a lot to absorb, but that's all we had on the online side. If you had to do it offline, let me just bring that up. So for the offline, I'm just using FileZilla. You don't have to use FileZilla. You can use any file transfer for whichever your company allows or your IT allows. So I'm SFTPing to the clock, and then I want to look at the configuration. So I'm just putting it the syntax for that. I'm going to be putting username NovaTech, password NovaTech, and port 22. I'm going to be quickly connecting to it. It's going to ask, since I was already connected, it's asking me, do you want to abort the previous connection? I'm going to say yes. And so this is where the file is in the clock. And then this is where I have it on my local laptop here. I'm just going to open that file in the notepad in a minute. So we recommend you to open in a notepad or a notepad ++, something like that, not Word, because it adds other layers to it. This is where the offline files are. It's very handy if you've got multiple clocks in your stations that you just want to make sure everything is done offline, and you should be able to send that. I've used the antenna delay is something that can only be done offline. I've done fake GNSS because I don't have an actual antenna right now based on where I'm staying. So I force this to go through, and then I'm also defining the clock and the time. Once this metric, say the time now is 11:38, I would just save this. On the left-hand side is my change. So I'm just going to drag this and overwrite this file. And the time and date should be updated. So this is the offline method of doing configuration. That's I had on the offline. And Ben or Nate, do you have anything else to add on?
No, I think that's good. Did you want to show that we do provide, I'm not sure if you were going to, some default configuration files through the NCD?
I think, yeah, it's probably we're going to talk about that you
Okay,
can have.
perfect.
Yeah, we were going to say on the MIB file are available, so you can get all the data from the NCD and pull all of that from the clock. So we do have that option. In case you need the templates for that, please reach out to one of us and we should be able to help you out with that. That's overall the demo. We can take any questions right now.
Oh, thank you, Rob. Oh, go ahead.
Yeah, I do see one more question from Micah that just came in around the UI UX for the online configuration, whether it'll be further aligned with the Orion style. I think yes, that is a long-term goal. I can't give you a time frame on that, but we certainly do want to make sure that all of the products are kind of harmonized. So that is a direction that we're going, but again, I can't give you a timeline just yet, but it'll certainly be more refined as time goes on.
Thank you, Nate. Well, Saurabh, I don't see any other questions coming in.
Yeah, we can give a few minutes for that while we just talk about our community and support side.
Sure.
So yeah, we'll wait for the audience to ask more questions. So also wanted to reflect our community site, novatechautomation.com/community. In this site, you can find user manual, tech notes, data sheets, certification, and similarly, power hours are also there. What are some of the past power hours? What are some of the upcoming webinars? So feel free to sign up for new events as they happen. And then on the support side, you can find, you can download NCDs, the firmwares, each product line, whether it's Bytronics, Kronos, or Orion products, anything with release notes. And then also one feature is My Files. So if you have some settings that you want to share with us, you're more than welcome to share it on My Files. That's on the support side. And then feel free to book any one of us. We have a team of, you can see all the sales engineers are available to help. If you do come across any issues or you want to know more on a certain product line or any solution that we offer, feel free to book us anytime, available on this booking.novatechautomation.com. We should be more than happy to help you with any query that you may have. That's all I had on to present today. We can certainly wait for more questions if there are any, but thanks everyone for joining us for the Power Hour. I hope that was informative for every one of you, and we'll talk soon.